This is problem 11.2 from chemistry. A chemist produces hydrogen gas in an experiment and collects that gas in the presence of water. If the total pressure of gas collected was 1.115 atmospheres and the temperature was 26 degrees Celsius, what was the pressure of hydrogen gas collected? Now, this type of problem requires you to remember a couple of things. The first is that the total pressure is equal to the sum of all of the gases that are present in that mixture. That's part of Dalton's law, that the sum of the partial pressures of each gas, doesn't matter what gas they are, the sum of those gases equals the total pressure that that gas mixture exerts. Now, the second thing you have to remember is water. There is always, or even any liquid, but in this case it's talking about water, right? There is always pressure being exerted on the surface of that liquid, in this case water, and that's the water vapor pressure. So if hydrogen gas is collected in the presence of water, you know that the total pressure is not just the pressure of the hydrogen gas, but the total pressure will be the total partial pressure of hydrogen gas plus the pressure of the water vapor. And so always when you do these types of problems is to write down what you know and what you're looking for, right? We know we're collecting hydrogen gas. We know that the total pressure that the mixture of gas exerts is 1.115 atmospheres. We know that the temperature during which this experiment is being run is 26 degrees Celsius. We want to know what is the pressure of the hydrogen gas alone, the partial pressure of hydrogen. What we have to remember is that since this phrase right here, in the presence of water, it means that the water vapor pressure, it needs to be factored in as well. So we're going to use Dalton's law that states that the total pressure of the mixture of gas is equal to the sum. So in this case, the total pressure is equal to the partial pressure of hydrogen plus the partial pressure of water vapor, and I just used a subscript WV here. Now, with water vapor, again, this is dependent on the temperature, and so you have to go back and look at the chart that is in your book, and if you find 26 degrees Celsius, you will find that the pressure of water vapor is 25.2 torr. So that's all well and good. We have all of these parts here. However, we have one issue, right? The total pressure is given in atmospheres, and the partial pressure of water vapor is given in torrs, so that we must convert. And honestly, it doesn't matter which direction you go, you should get the correct answer. In this case, you have to remember the conversion factor, that 1.00 atmospheres equals 760.0 torr. And so if I have, I'm going to convert to torr, so I have 1.115 atmospheres, and I'm going to multiply that by 760.0 torr over 1.00 atmospheres. This allows to cancel out the atmosphere, and the final answer is in torr. Now there are 1, 2, 3, 4 significant figures here, and 4 here. So we want to have 4 in our answer. So we have 847.4 torr. And if we take that, actually here I showed you how to do it twice. You can also convert that 25.2 torr to atmospheres, and in this case you would divide 25.2 divided by 760.0 torr, and that would equal 0.0332 atmospheres. And in this case, since torr has only 3 significant figures, we can only have 3 in our answer. And so we just simply then, once we have the correct units, we plug it into Dalton's law. So the total pressure, 1.115 atmospheres, equals the partial pressure of hydrogen plus the partial pressure of water vapor, which if it's in the atmosphere is 0.0332 atmospheres, and we simply subtract that 0.0332 atmospheres from both sides, which leaves us on the right hand side of the equal sign. This is just simple algebraic maneuvers. So with the partial pressure of hydrogen is equal to the total pressure minus the partial pressure of water vapor. And again, we only want 3 significant figures, and our answer is 1.082 atmospheres.